This is a Silver Bullet Security Podcast with Gary McGraw. I'm your host, Gary McGraw, CTO of Cigital and author of Software Security. This podcast series is co-sponsored by Cigital and IEEE Security and Privacy Magazine, where a portion of this interview will appear in print. For more, see www.computer.org/security and www.cigital.com/silverbullet. This is the 113th in a series of interviews with security gurus and practitioners, and I am happy to have with me today Chandu Ketkar. Hi, Chandu.
Hi, Gary. How are you?
Chandu Ketkar is a technical manager at Cigital, where he's focused on architecture analysis and code analysis for several years. Chandu has over 20 years of experience in the software industry as a developer, manager, and entrepreneur. Past positions include work at Alcatel, Swift, IXI, and Plutopian. Chandu has an MS in computer science from Virginia Tech and an MS in EE from IIT. Chandu lives in Virginia with his family. Thanks for joining us today.
Thanks, Gary. Thanks for having me.
So, as a person who worked as a developer, what sort of insight can you give us on the mind of a developer as opposed to, say, the mind of a security person?
Very good question. So, having worked as a developer for a long time, developers are really focused on building features. And they're really, today if you look at a typical developer's life, they are going from sprint to sprint to sprint. And the focus is on getting things done and not always getting things rightly done. And that's where security guys, their focus is how to get things, how to architect things in a secure way, how to code things in a secure way. So security guys bring that focus, which is lacking for lack of time and a lot of other factors when you're doing software development.
Do you think that the fact that software developers are taught and managed to think about features and functions make them think that security might be one of those instead of a property of a system?
No, it's about the culture in the company. So I have worked in some companies where security was part of the culture of the development teams. And then there are other companies where I have worked where security had no role to play. It was all about features. So it really flows from top down. That's how I kind of look at it. And since I have joined Cigital, and sorry to kind of expound on that a little bit, I have now begun to think that we are really playing on the same team more and more, the developers and the security people. And from myself, I think that if I had the security knowledge that I have today, it would make me a lot better developer.
Back in the past. Wouldn't it be fun to go back and fix all your old code?
I would love to have a time machine to go back in the past.
So what can software security do better to appeal to developers and architects that may not know too much about security yet?
Part of it is education. And I like to connect dots. So if you look at economics, there is a principal-agent paradox in economics. So we are the principals of security. We own the security problem, the security people, but we are not the agents of change. When we say that, hey, we need to design something in a secure way, or hey, we need to code something in a secure way, the agents of change are the engineering teams. The us versus them mentality, which exists in some corners of security world, I'm not a big fan of that.
Yeah, me either.
I think we are really, we need to take a lesson and take a page from how principal-agent problem has really revolutionized boards and managements. They're playing on the same team. I think we need to start doing the same in security. I'm very hopeful that we are leading in that direction.
Can you give me an example of a domain where that pattern existed and then it went away or was supervened, or not supervened, was fixed, I suppose?
I think the whole genesis of incentive stock options, ISOs, is precisely or expressly created to bring the agents who are the management of a team in line with the principals who are the shareholders and the board members of a team. And incentive stock options have aligned their interests. And I think we need to really figure out how we can do that in security.
That's interesting. Let's talk about some of your past work. One of your projects at Cigital a million years ago was this thing called ESP, which focused on automating analysis, static and dynamic analysis, and combining results in sort of a sophisticated package. What lessons did you learn from working on ESP with regard to tools and their actual use out there in the real world?
Yep, I learned 2 lessons. And one of the lessons, John Stephen made me aware of that today's tools, they're good, but they're leaving out large class of problems. So for example, if you take a tool like a typical static analysis tool like Fortify, it works well in some environments, but when you start using dependency injection frameworks, for example, where code is wired at configuration at runtime, these tools don't do a great job. So there is this depth problem. But the more fundamental problem, as I see it, is the integration problem. You go to a big enterprise, and they have 10 vendors, 10 different tools, producing 10 different reports, 10 different business processes that are looking at those reports, trying to mitigate. So it's a much bigger integration problem. And I think bigger organizations need help in that space. So when I was part of ESP, I tried to fashion ESP as an integration platform, saying, hey, you can bring your white hat results, Fortify results, all types of results, binary Veracode results, and we can normalize them so that you have a single findings database, and then you can work off of that.
I guess that makes it easier to figure out what to fix.
Yes, that makes it easier what to fix. And first of all, if you're a manager, you really want to get a holistic view of what is happening and not just going to different silos and saying, hey, what's happening in static code? What's happening in white hat? You really want a holistic view of your security landscape. And that is not possible unless we have supporting tools and infrastructure built for that.
So let's talk about code review tools a little bit more in depth. Code review tools have been around for a decade, actually slightly more than a decade, and they're all the rage, but they really don't even begin to scratch the surface of design. Why not?
Well, if you look at any software development activity, when you're talking about code reviews, you're already late in the game. Design has already happened. A lot of the main decisions have already occurred. Okay, whether I'm going to use a two-factor authentication, whether I will use a token-based authentication, that decision has already been made before it goes to coding. So to me, fixing problems in coding is kind of late in the game.
Mm-hmm. You have to do it to catch bugs, but there are also flaws.
Oh yes, there are flaws. So you're going to catch some stuff, but you're going to, your research and even independent Microsoft research shows that 50-50 split is pretty widely seen between flaws and bugs. So you're just not going to be able to catch flaws when you're looking at code.
So let's talk about software design and security a little bit more. Why is architecture risk analysis important for understanding security posture of a piece of software? And how does that really differ from code review? Code review, we can use a tool. What do we use for architecture risk analysis? And what are the key steps?
Yeah, so architecture is, you're really broaching into a big area here. So the foundation of architecture risk analysis, which I like to say is the foundation of most of the security activities, is threat modeling. So threat modeling is a real fundamental piece that allows you insight into the threat landscape of your application or the system. Once you have that understanding, it can drive many decisions in your SDLC. And what are those decisions? You could use threat modeling to drive security requirements. You could use that to drive pen testing. You could use that to drive security testing by creating abuse cases, security test cases. If you just look at security touch points from Cigital, all these ideas are very well expressed in that model. Architecture risk analysis is different than threat modeling. And
okay, let's try to get to the bottom of that.
Okay.
How are they different?
So threat modeling is fundamentally a technical activity that connects your risk. It is basically looking at the threat landscape and all possible threats that could potentially compromise your application. And you identify assets, threats, potential controls you may need, and so on and so forth. And it's a very fundamental activity. However, when you wear a businessman's hat, you have limited resources to spend. Okay, you can't fix every problem. All right, so which problem should I fix? Which threat should I be looking at first? That's where architecture risk analysis comes into play, because now we are talking about a different paradigm, which is the risk. We are in the risk landscape now.
Risk management land.
Correct.
Okay, so talk about what kind of steps go into an architecture risk analysis in your view.
Yes. So in architecture risk analysis, there are two fundamental things that we do. One is to understand the business context. So we understand what are the business objectives, what are the business risks. So that is one strain of understanding.
Yeah, so you answer the who cares problem. Correct.
And why should I care? Okay, if I lose this data, what damage does it do to my brand? Okay, I mean, should I fix it because the security guy is telling me to fix it, or should I accept the risk? I mean, those types of decisions can really be driven by doing business risk analysis to some extent. And then we do threat modeling as a second piece, where the details are, we decompose the system. Mm-hmm. Then we fundamentally focus on any two systems that are communicating across different trust zones, because that's where we find most of the problems. That's where most of the assumptions get violated. So we continue through this decomposition and modeling of the system. Once we do that, then we start identifying assets. And again, we always wear a security analyst hat. So assets are something that are important from security viewpoint, which means if they're compromised, it has some business level impact. Then we find out what threats could compromise these assets, what controls we could potentially implement. So, and when we are doing our analysis, we obviously look at known attack analysis. So we have a large library of attacks that we know.
Right. So those are written down in advance.
Correct.
Or known in advance.
We have checklists that we use. Then we understand that we understand all the dependencies. We look at the dependency risk. So we look at basically holistic. We take a holistic risk view when we do threat modeling, and then we tie those results with the business analysis, and then we prioritize risks, and we say that we believe that threat modeling suggests that these findings are really high priority and they would have big impact if you guys did not fix those findings.
So this sounds like a lot of work. How do you scale something like that?
That's a great question, because threat modeling and AR architecture risk analysis, as much as I love it, I find that our clients and most companies I have worked with, they are struggling to apply this across their application portfolio. So right now, the application of these architecture risk-based services is really to highly critical applications, which is not right.
So they're not scaling across the portfolio.
Correct.
In all.
So scaling is a problem right now, and we have come up with some solutions, and we have some really neat ideas that we are working on right now. So, for example, let's look at threat modeling. So, Gary, you talked about threat modeling. So there are a couple of issues when you go into threat modeling and ARA. One is a scaling issue. Other is a consistency, reliability, and efficiency issue. And there are two separate issues. They are linked, but they are two separate issues. So how do I improve consistency of my threat modeling? How do I make it reliable?
I guess writing stuff down helps.
Writing stuff down. So let's talk about Stride, okay? Because Stride is used.
This is Microsoft's
approach to threat modeling. Yeah. And I just want to point out where Stride kind of does not work. So if you look at STRIDE, so spoofing, tampering, escalation of privilege, whatever.
Information disclosure.
Correct. These are all really impacts of attacks. So when you look at tampering, how many ways can you tamper data? Well, I can tamper data on a communication channel. I can tamper it in the database. I can have memory-based attacks. I can tamper data all over the place. So when someone is using Stride, when they look at tampering, when they focus on tampering, they need to have checklists to ensure that they are covering all the attacks that could tamper data. And that's where we found, I worked with a couple of clients, and I found that they used Stride, but they were highly inconsistent, and they were not getting the results that they wanted.
I guess what happens is if you have experts that are doing this and they're pretty good at it, they have this list in their head, but they might have a different approach than some other expert in the next cube over.
Correct.
Yeah. So there's a lot of work to be done there, clearly.
Again, we could take a page. We could learn from some other industries, Gary, and I like to connect dots always. So, for example, there's a great book called Checklist Manifesto. Okay.
I like the title.
And it is written by a Harvard doctor, and he tries to change the healthcare industry, because 15 years ago, all the surgeons, they looked down upon checklist.
Oh, yeah. So this is the guy who worked on the critical care stuff.
Correct.
Yeah.
And he learned from the airline industry. And it's a very interesting story he tells. And if you give me like a minute. So the B-17 bomber, the legendary B-17 bomber from Boeing, that Pentagon bought, it lost, when they went for a test flight, one of their most senior pilots, he crashed the plane and he died. And Pentagon was trying to figure out what's going on. And then they realized that the plane is too complicated to fly. That was the first time it was a 4-engine plane and they could not fly the plane. So Boeing came up with checklists, and that was the real genesis. That was the beginning of checklists, pre-flight checklists, in-flight and post-flight. And that has made commercial aviation today, which learned from military, commercial aviation has become very safe now. And I think same thing is happening in healthcare. Surgeons who jeered at checklists, thinking they are smarter than checklists, are using checklists very successfully. It is increasing reliability in the healthcare industry. And I think security is no different. We need to really say that, okay, you know what? We need the Amits of the world and John Stevens of the world to solve the really hard problems. But there are 70-80% of the problems that are like so mundane and so well known and so well researched. Let's write them down, let's write their solutions down, and let's create some checklist-based approaches that give us reliability and consistency.
So we tried to do that with the IEEE Center for Secure Design work in the beginning. Have you found that work to be of use?
Yes, absolutely. At a high level, I think it gives me a good framework to think about. But what I'm talking about is more at operational level. So for example, pattern-based threat modeling. So when we decompose a system, we always see REST services, SOAP services, databases, enterprise service buses, message queues. We know when we see a REST service what to look for. So can we use an 80-20 rule and say, let's write down what threats I should be looking at, under what circumstances those threats are applicable, so write some applicability criteria, because not every system, every threat is going to apply. And once a threat applies, we know what controls we need to use to mitigate that threat, which eventually drives your security requirements, abuse cases. It can really, I believe, change the way we do threat modeling.
Yeah, and ultimately, you just want those designs to be done right in the first place. So I suppose design patterns are the ultimate goal of this kind of work.
Correct. So I think the other area where I'm doing a lot of work right now with some folks at Cigital is security architecture patterns. And that solves a different business problem. And the business problem it addresses is we are getting better at knowing what the right things are from security viewpoint, okay? So I know what the right thing to do. But how to do it right, how to operationalize it, and that's where I think we have some challenges. So for example, if you go to a big organization, they have policies and standards that enshrine their security requirements. And now we need to take those policies and standards and drive those through engineering teams so we do the right thing. And we need to give some tools in the hands of our security people and engineering teams. And security architecture patterns is one of those tools. So when you say you want to use OAuth or you want to use a token-based authentication system, you understand what the best practices are, what the risks are, and you have real actionable guidance.
We'll be right back after this message. This is Gary McGraw, your host for the Silver Bullet Security Podcast. If you like what you're hearing here, you should check out my monthly security column published by Search Security and Information Security Magazine. You can find the most recent column at searchsecurity.com/McGraw. All of my writings are collected on my webpage at www.cigital.com/gem/writings. Thanks for listening. You've been active in the medical device domain. We've even written about this together, you and I.
Yes.
What kind of errors do you often find in medical devices? And I know you take a holistic approach to this when you do these sorts of things yourself. So it includes ARA, but it also includes things bigger than that, I suppose.
Yeah.
So what kind of problems are you typically finding in today's medical devices?
Yeah, so medical devices, they're fundamentally different from a lot of other embedded systems that I have looked at because their lifespan is very long. So they exist so something that was built in like late 80s or even mid 90s is operational today. So what does that do? Well, you as a security guy, you can go and say, yeah, do RSA encryption or do AES 256. And they will say, well, I can't do it. I don't have that firepower. I'm
not enough computation.
Correct.
Yeah.
So that is the first problem we have to deal with as experts. And the second problem I found is the context in which some of these devices operate really require us to create more pragmatic and innovative solutions. So just to give you an example, I looked at a couple of devices that were used in operating rooms. And you turn that machine on and the machine, it began working. The machine contained patient data. And my first reaction was, hey, is there no authentication? You
just turn it on?
and they all began laughing. And they said, oh, no. Doctors will never authenticate because this is a brain surgery equipment and it better turn on and work, okay? So we have to really balance now here security and the context in which the machine is being used. So it really compelled me to think hard and create innovative solutions. So we have to accept the reality. So going back to your original question, Gary, so I'm finding all kinds of issues. Yeah, starting from physical security. A lot of these machines, you can simply JTAG and get the firmware out. Platforms are not hardened. I mean, if you just look at the most current Hospira drug pump discovery,
right?
That is really the drug pumps are accepting any firmware. Okay, they don't care about whether the firmware is signed. They don't care about the provenance of the firmware, which is really security 101. So you're really seeing basic issues when it comes to security. The second thing I found. Which is medical devices operate in an environment. There are two security concerns. One is a patient safety concern.
Yep.
Other is a privacy concern.
Yeah, and I think that HIPAA has made people pay more attention to privacy than safety, which is a high irony because I don't think you care about your medical data getting lost if you're dead.
Well,
I mean, I wouldn't.
That's an interesting way to look at it, Gary. But if you look at, I have done some research, and medical data is fetching a lot of money in today's black market, and because there's a lot of scope for insurance fraud. So if you look at like what happened at Anthem, right? Someone got hold of admin password to the database, and they stole 80 million records. I mean. I simply cannot fathom. When I read the Anthem story, two things came to my mind. I'm like, had these guys, we should have thought about separation of duty. I mean, this is like a very fundamental security principle. One admin has access to 80 million records. How is that possible? The military has solved that problem long time back, right?
Yeah.
And second thing is defense in depth. I mean, today's databases support features such that if I give a query and if it results in 80 million rows to be returned, the databases will say,
not so good.
I'm not going to give you that. So like Oracle supports actually max rows to be returned from a query. So you can have defense in depth, you can have separation of duty. So a lot of these things were missed in case of Anthem.
So We're currently building BSIM 6 this week and next week, which is going to include a healthcare vertical. Care to hazard a guess about how healthcare security compares to, say, I don't know, financial services security? What's your guess?
I think I'm not even guessing here. I know.
Well, what's the answer then?
The answer is financial security is way, way better than healthcare security.
Yeah, and that's what we're finding. So the good news is that healthcare as a vertical is beginning to pay attention to this, and they're starting to work on it. But boy, do they have some work to do.
Yes, and this is actually very interesting. When I gave a talk, and thanks to you, Gary, in Archimedes conference.
Oh yeah, up at University
and
of Michigan.
I simply shared my findings based on the assessments I had done with medical devices. And here comes a company from Boston, BitSight, their CTO, and he's only using publicly available data. And he reached the same conclusions that we at Cigital had reached.
Without really looking at devices.
Correct. So external view and internal view are really in sync in this case.
Yeah, that is very interesting. So thanks. This has been good. I got one last question for you. What's your favorite piece of Indian classical music?
Oh, okay. That's going to be a long answer.
Well, you have to hold it to 30 seconds or less.
Yeah, so I'm trained Indian classical musician, so I like Jaipur style of singing, and I like Kishori Amonkar, who is one of the real exponents of that style of singing. Mm-hmm. I like her. But I enjoy all types of Indian classical music as well as Western classical music.
So send us a URL and we'll stick it on the website here.
Absolutely.
Great.
I will do that.
Thanks a lot. This has been very interesting.
Thanks, Gary.
This has been a Silver Bullet Security Podcast with Gary McGraw. Silver Bullet is co-sponsored by Cigital and IEEE Security and Privacy Magazine and syndicated by Search Security. The July-August 2015 issue of IEEE S&P Magazine focuses on multidisciplinary security. The issue also features our interview with Katie Masuris. Show links, notes, and an online discussion can be found on the Silver Bullet webpage at www.cigital.com/silverbullet. This is Gary McGraw.